Hello, welcome to my YouTube channel. So today I'm doing a basic overview of chemical reactions and how to balance them. I'm sorry if my voice doesn't sound too great. I'm still coming off of a pretty bad sickness, but I'm hoping it's not too bad. So I won't be going into too much detail about like the basics of compounds and things similar because I'm assuming if you're looking for this kind of help, you'll already know most of that. If somebody does happen to request a video about more basic information, that's something I would be willing to do. Um, I drew up an example that should be useful for understanding how things work. I will go into some basic stuff like understanding charges and things similar. So you can see here, I put the charges of aluminum and nitrate above them in the equation. So there's two aluminums and three nitrates in the equation. Aluminum has a positive 3 charge, while nitrate has a negative 2 charge. And then underneath it, because I'm doing this illustration on a phone, so I don't have a lot of room to do things horizontally, but the addition symbol will go to the beryllium phosphate down here, which beryllium has a positive 2 charge, while phosphate has a negative 2 charge. Um, Sorry, that's my cat. Go away. Stop. Not right now. Um, so you can see here the 3 at the beginning of beryllium phosphate because I already balanced the equation beforehand. But if we go down here, since this is a double displacement equation, you can see the products. There's an aluminum phosphate and a beryllium nitrate. Now, we understanding how to balance equations, you know the charge. So if you go down to beryllium nitrate, you know nitrate has a negative 2 charge and beryllium has a positive 2 charge. But if you look up here, we know that we have 3 nitrates. And because aluminum has a positive 3 charge while phosphate has a negative 2 charge, that's an imbalanced equation. So we know that we need to do something to get 2 to go into three's multiplications. So we know we'd have to find the lowest common multiple, which would be 3, because if you do 3 times 2, that equals 6. 2 times 3 equals 6. So we know we have to have 3 phosphates in order to balance it with 2 aluminums, because that's the lowest amount of aluminums that would go into phosphate. And to get 3 phosphates, you wouldn't do parentheses 3 on the phosphate because that would imbalance the equation. And you also need the 3 berylliums to do down here to balance with the nitrate. So you'd put a 3 on the end. This is called a coefficient. You put the coefficient on the beginning of a combination of elements and compounds to signify that you're doing 3 of the entire thing. If you do beryllium 3, phosphate 3, that would look like you're doing 3 berylliums and 3 phosphates, which is incorrect, and you would not get that problem correct on an exam. So you have to specify with a coefficient. And then you scroll up to here. Now we can look down and see we've done the phosphate balancing to balance with aluminum. And we have 3 beryllium nitrates, which 3 nitrate, 3 beryllium. You scroll down here. This is something that my teacher taught me to do, which is helpful, is to lay out how many of each portion of the equation we have and then check them with the starting values. So starting with nitrate, we have 3 nitrates in the products, which lines up with how many we have at the beginning. So you can mark that out. 3 berylliums, which lines up with the beryllium phosphate with its 3 coefficient. We have 2 aluminums, which lines up with aluminum nitrate up here. And we have 3 phosphates, which lines up with the coefficient that we put on beryllium phosphate for the starting values. I hope that was a pretty concise example and description of how balancing works. It does get a little more complicated depending on which unit and what form of balancing you're doing, but most of the time, this is what you'll have to do for any chemistry class that is not advanced placement or some form of college level course. So, to summarize everything, we had to balance the charges of the compounds as well as the amount of each section that is in everything here. So we balance the beryllium nitrate with the amount of beryllium and the amount of nitrate, and we balance the aluminum phosphate with the amount of aluminum and phosphate. You just have to make sure that you never have an unequal amount of one part of the equation on either side, not in the products or the reactants, because if you have an unequal balance, that is not a balanced equation. And you also have to make sure that before you do balancing, you have your charges done right. If I hadn't done phosphate 3 here, I would have done aluminum 2 phosphate to balance aluminum. And then I'd have 2 phosphates left over because I never balanced this equation to begin with, which would have made it incorrect. So you always do balancing first before you start looking at how you do coefficients and lining things up so that the reactant and product side have the same amount of every portion of the equation. And if you ever need to double check that, doing this down here, writing them out, and then scratching them off as you check that they're balanced is always very helpful. I hope this is useful to anybody who was not completely sure about how to balance chemical equations or who just was curious about it. And I hope anybody who's watching this does good on whatever test or exam they're about to have and has a great day.